When I reviewed the work from the previous example, I recognized that I made a critical error, and the critical error that I made is right here. Notice that in this previous solution step, I multiplied both sides of an inequality by a negative number. And we know that when we multiply or divide an inequality by a negative number, that we have to reverse the direction of the comparison symbol. I failed to do that. So I've marked the incorrect statement that I had written previously out and replaced it with the correct statement where I've reversed the direction of the comparison symbol, saying that y is less than -8, and notice that that coincides with the solution set, the shaded region of our graph. Okay, one last thing that I want to deal with in today's material, and I want to take that previous standard form inequality and I want to take a different approach. I want to solve that by manipulating it so that it's in standard, or we're going to go from standard form to slope-intercept form. So our inequality was 2/3 x minus 1/2 y is greater than 4. So we're going to do a series of algebraic steps using our mathematical properties to isolate y and get this equation in standard form, this inequality in standard form, into slope-intercept form. So the first thing I want to do is recognize that this 2/3 x is on the same side of the inequality with y. I want to perform an operation to make that 2/3 x a 0. To do that, I'm going to add the additive inverse of 2/3 x to both sides of this inequality. So it looks like this. Add a -2/3 x to this side, and add a -2/3 x to this side, and that's the result of applying the additive identity property along with the addition property of equality. So the result, a positive 2/3 x and a negative 2/3 x is 0. Mission accomplished. So we're left with 1/2, or negative 1/2 y is greater than, notice they were adding a negative 2/3 x, so negative 2/3 x plus 4. This original 4 in our inequality was positive, so we have a plus 4. Next step in the solution process is to recognize that I'd like to perform an operation that makes the coefficient on our y variable term a 1. To do that, I'll use the multiplication property of equality and the multiplicative inverse property to multiply both sides of this inequality by -2. And that's because -2 is the multiplicative inverse of -1/2. So we'll multiply -2 times -1/2 y is greater than, and -2/3 x plus 4. And notice when we multiply both sides of this inequality by that value of -2, I'm going to have to apply the distributive property on the right because we had a sum. Not just a single term, but a sum. So the result, -2 times -1/2 is 1, so that leaves us with 1y. Notice that we multiplied both sides of this inequality by a negative value, so I have to reverse the direction of the comparison symbol. So less than, y is less than, -2/3 times -2 is -4/3, so -4/3 and x, whoops, made a mistake again, -2 times -2/3 is +4/3, so 4/3 x plus negative 2 times 4 is negative 8, so minus 8. So we have the resulting slope-intercept form inequality is y is less than 4/3 x minus 8. Let's plot the solution. So again, same process that we began with, using the 3 steps. I noticed as well when I did that last example, I failed to label the x and y axes, and my bad. Now I'm going to plot the y-intercept, which is a negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Downward because it's in the negative direction, or we have a negative value. And then plot slope triangles using 4/3. Count up 4 and right 3. So 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. And we've got 2 points there. Notice our comparison symbol does not include the equal part, so we'll connect our points with a dashed line. So knowing that the boundary line, the boundary condition is not a part of our solution set, we'll check 0, 0. So we'll see is 0 less than 4/3 times 0 minus 8. Is 0 less than negative 8? The answer is no. So 0, 0 is not a member of our solution set, so we know we have to shade the side opposite 0, 0 in our boundary condition. So 0, 0 is not included, so we have to shade the side that does not include 0, 0 in our boundary condition or in our solution set. And so the solution, graphing that inequality, the shaded region includes the solution set to our original inequality here. Notice that that was a good bit more work than was required when we used the option of plotting the x and y intercepts. So I'll leave it to you to make a choice about which one you prefer. However, having both of those skills in your toolbox, in your mathematical toolbox, is really something that I want to encourage you to do, to develop both of those skills so that you can use them in a variety of cases. One might be appropriate in one place, whereas the other in another. So here we've managed to plot the solution set to that original inequality.